Hi, this is our video for CVM 7. And before we start, I want to remind you the goals for the Buggy Lab that we did on Friday were to calculate the slope of your graph and write the algebraic model. And if you could, try to come up with a name for the slope of that graph. So I wanted to show you a couple of people's work so that we could compare what people came up with. We've got Jalea and Joemi and Justin here. They were working with a blue buggy, and you can see they got pretty straight line here. They calculated a slope of 21.4 centimeters per second. And the name that they came up with was movement. Actually, Joemi thought that we should call it speed. Jalea suggested movement. There's just definitely a connection between movement and speed. I'll show you some more work. We've got Wendell and Jorde's work here. They were working with a red buggy, and notice they calculated their slope to be negative, which is interesting, and it was much faster. That is, it was 56 centimeters per second. They decided to call it positioniness, kind of going back to this idea of bounciness, but connecting it to this position graph. Notice the red buggy that they used was a way higher number than the blue buggy number. Many of you noticed the blue buggy travels slower. So Joemi's suggestion of calling this speed does indeed make some sense. Let's look at another piece of work here. This is Esther and McCoyan and Kiara and Anya. And they decided on the name rolliness because we got this cart rolling down the track. They calculated the slope for this red buggy as 40 centimeters per second. Now, this red buggy, when we collect this data, is always going to end up with a steeper slope than the blue buggy. That is, red buggy slopes tend to be around 40 to 50 centimeters per second, whether that's positive or negative, and blue buggy slopes tend to be around 20 centimeters per second. Here's Musa and Milka's work. They calculated that slope as 18.46 centimeters per second. That is, they were using a blue buggy as well. So we can tell these blue buggy slopes are always smaller than the red buggy slopes. Blue buggies always move slower than red buggy slopes. I really like this idea that a lot of people came up with, that we should call this slope speed. The word we're going to use is related to speed, but it's not quite speed. And I'm going to point something out because there is a word up here that we haven't yet unlocked. We unlocked force, gravity, friction, energy, but we have not unlocked All right, thank you for that, Mr. Eichten. This is actually a very exciting moment for us. We've been trying to unlock this word for a while. Velocity is the slope of a position versus time graph. And the abbreviation we'll be using for velocity is a V. The units we'll use are centimeters per second or meters per second. That is some unit of position or displacement over some unit of time. And notice that that comes from the slope calculation. If we look at, for example, Kevin's work right here, if we do a rise of 200 centimeters over a run of 10 seconds, that gives us units of centimeters per second. That's where those units come from. Notice that velocity is a vector. The magnitude of a velocity vector is referred to as speed. So that's where this word is coming from. Yes, a red buggy is going to have a greater slope number than a blue buggy because the red buggy moves faster, but it's also important to point out that depending on which way your buggy is pointing, you're going to end up with a different slope. For example, Kevin's group, which included Kevin, Latia, and Quaylen, worked really, really well today. Their position numbers increased. This looks like a positive slope, and they ended up with a positive velocity. Whereas, looking back at Esther and McCoyan and Kiara and Anya's group again, they were working with a buggy that was pointed towards the 0 point in the negative direction, and they ended up with a negative slope. You can tell this looks like a negative slope like we know from math class. So we want to point out this by comparing two graphs. We'll say positive slope means positive velocity. As an example here, that could look like this. And we could also see, so this is a graph of position versus time. We could also see on that same graph of position versus time, if we saw a negative slope, we would want to remind ourselves that negative slope means negative velocity. That is, when we're working with this slope calculation, we need to actually be able to look at the slope and use our knowledge of positive slope and negative slope from math class.